Hey guys, so focusing on translation today, and I have it set up a little bit differently. You see, the board is now smaller. I need to have on that side here that big wheel for coding purposes. So I just wanted to say before we get started, little trick here. I'm not going to talk about translation details. You have a lot of information in the PowerPoint and in the videos online that I had on Blackboard. But what I can tell you is what the heck do you need to know, right? So in transcription, we talked about how to go from DNA to RNA, right? And now we are stuck with RNA, and that RNA molecule is somewhere out of the nucleus and in the cytoplasm, right? I put it on the side over there. And your question is, how do I get from RNA to proteins? All right, let's do just protein, just one. And remember, RNA is a sequence of DNA with U's instead of T's, right? It has been transcribed. Transcribe means you just, like a monk, remember, you just transcribe from a book to a page, but you have the same language. Just saying, change some letter, but you have the same type of language. Now we're changing completely because we're going from a one strand to something that has amino acids. And so how do we do that? Well, we use that code. As you can see here, there are different representations of the codes. You can have a first here, the first codon. So a codon, let's talk about it first. Really important, the codon is a unit containing three different uh, nucleotides. So 3 by 3, your RNA is going to be read. So if you start, let's say A, U, G, starting codon. A codon is the three of them together that will be at the ribosome between the sub and the two subunits of the ribosome, the small and the big. That codon will match an anti-codon on the tRNA. So all of those details you need to know, you can watch videos. But what I want to tell you now is what are you going to have to show me as your skills at the exam. You're going to have to go from RNA to protein, and of course you will be provided a code. I show you this one in a wheel shape just to tell you other things that exist. But let's go to a more familiar one when we have a table with the first, second, and third letter over there, right? How about that? Sounds better. So once again, there's no time like the present, and just make it up. Just make it up, right? So we're going to start making up a little RNA sequence. And once again, just go with your guts. You don't even need to have a start codon first. This is just to learn, right? This is to learn how to go from RNA to protein. So I'm going to be A, T, C, G. Oh, look at that. Cannot have a T. It's RNA. A, U, C, G, C, C, A, G, A, C, A. There you go. I got a sequence. Now, how do I do that? Well, I'm going to break it down first thing first in trios. That's really important. That will really help you. So let's see. I'm going to break it down in a trio here, then three more there, three more here. Here you go. Oh, look at that. I didn't even plan that. No, trust me, I did not. So now that I've got 3 by 3, I'm just going to refer to the table. And I'm going to start writing down the actual sequence of amino acid. So let's see, A, U, C. So first base here, A is here, right? A is here. I hope you can see my pointer right here. Maybe not. I found a cool trick. So A is here. Look at that technology. U, then the second one is right there. And then C. See, if you wonder I didn't find the trick immediately, I can pause the video before I start recording again. So A, first base, second base U, and then C, so it's going to be ILE. And I will write it this way, right? And we're going to make a little dash to symbolize the attachment, the peptide bond between the amino acid. And you know what a peptide bond is. We talked about it in the first couple of weeks. Okay, let's erase the markings. Now let's go to the second one, GCC. So GCO. Oh my god, I'm good at paint. And the third letter here, C. So G here, C, second letter. So I'm in the last row, second column, and in there I look for the C, the last one. So it's alanine. Note that it doesn't matter which is the third base. It will always be alanine. Redundancy is key in that code. Okay, let's erase that. Let's do the last one. AAG, A, second letter G, A. So it's third row, third column, and then G. So last row in that square. So it's lysine. And then lastly, we will do ACA. So it's A, third row, third column, and third row in the square. So it's again lysine. And boom, you got it. We just made a protein with 4 amino acids. Isn't that beautiful? And that's what you need to be able to do. So, of course, here I go rather slow, but if you can just keep it slow, do it steady, do it right. It's better than rushing and making mistakes. But you can also just look at the table and quickly get the column, make sure you break it by 3. And what I encourage you to do is just do it over and over again and maybe compare with others, maybe share with each other a sequence, and then do it on your side and compare your protein sequence. Do it with really long sequences, have fun with it. Maybe trick your friends by sending them a sequence of RNA with a stop codon at some places. So the stop codons are those two here, right? And is that one, the tryptophan here? Those are all stops codon. And if you include one of those, when they do the protein, they should stop. They should not do the next ones because they don't get translated. There's a stop codon. And little tricks like that. We're having fun as we can, okay? So here we go. That translation. Make sure you work through that because the goal is to be able to go from DNA to RNA to protein in one go. That's going to be on the exam.